Hi everybody, let's take a look at ACT Review Packet 4, Logs, Trig, and Sequences. We're going to start with the perform questions, there are 4 of them, and then we'll move on to the 35 on your own problems. We'll start with 19. 19, g of x is given as this function, 3x squared minus 5x minus 7, and what's the value of g of negative 2? Well, we can see that we want to plug a negative 2 in for x. So 3 times negative 2 squared minus 5 times negative 2 minus 7. Negative 2 squared is 4. 4 times 3 is 12. Negative times negative is positive 10 minus 7. So I get 22 minus 7, or 15, and that's choice D. Okay, 20. 20 asks, what's the domain and range of the graph? Well, domain are all the possible x values. And at first, it feels like the domain is maybe between negative 4 and positive 4. But remember, those are little arrows at the end. That means that function is not only going to go down forever, but the function is going to get wider and wider and wider. Also think about this as a downturn parabola. You can plug any number you want into a downturn parabola equation, like negative x squared plus 5. Is there any number you can't plug into that? No, they all work. So I think the domain for this is all real numbers. The range, however, when I look, goes down forever. So range would be negative infinity and goes up to 5 with a bracket. So which of these says the domain is all real numbers and the range is all numbers less than or equal to 5? That's choice J. 21. 21 says log base 7 of 7 to the 3/2 equals what? Well, if I use my power property for logs, I can bring that 3/2 down. Log base 7 of 7. Now, log base b of b, remember, is 1. So log base 7 of 7 is 1. So we get 3/2 times 1 equals x, where x equals 3/2. And so the question says here, x is between which consecutive integers? Well, 1.5 is in between 1 and 2, so choice A for number 21. And how about 22? 22 says, on her first day of ACT prep, Winnie answered 12 questions, and each consecutive day she answered 2 more. So 14, and then 16, and then this pattern will continue. Well, because this goes up by the same amount each day, we know this is an arithmetic sequence. And with an arithmetic sequence, the model is a sub n equals a sub 1 plus n minus 1 times d. Now, I notice that this isn't given to me in the equation, so I'm expected to figure it out. Okay, so we know that a sub 1 is 12, and a sub 2 is 14. D, remember, is the common difference, how much each term goes up by. Well, this goes up by 2, and this goes up by 2, so D must be 2. And so if I simplify this expression, I get 2n minus 2 plus 12 is plus 10. There's a sub n. Okay, and we want to know the value on the 30th day. So a sub 30 equals 2 times 30 plus 10, or 70. Now wait a minute. It says, how many questions had she answered in all? This is how many questions she would have answered on the 30th day. We need to know how many questions she answered over all the days. So we don't want the value of the 30th term, we want the sum of the 30th term. And remember the formula for sum of an arithmetic sequence, S sub n, is n over 2 a sub 1 plus a sub n. So the sum of 30 will be 30 over 2 a sub 1 plus a sub 30. Well, we just found a sub 30 over here, and we know a sub 1 is 12. So I'm going to have 30 over 2, which is 15, times 12 plus 70, or 15 times 82. And when I do 15 times 82, I end up with, J, 1230. And that's why this is a calculator test. Okay, so those are the first perform questions. Let's take a look at the on our own. Number 1. One says, find f of 4. Well, f of 4 means I plug a 4 in for all the x's of f of x. So, don't lose that 3. 4 squared plus 3 times 4 plus 4, which is 3 times 16 plus 12 plus 4, which is 3 times square root of 32. And we can simplify the square root of 32, right? We've got 2 times 2 times 2 times 2 times 2. We can pull out a 2 and another 2. So there's a 3 out there, a 2 comes out, another 2 comes out, and this 2, sad by itself, stays inside. So I end up with 12 root 2 for number 1. And that corresponds to choice E. 2. Doctors use this function below to determine the concentration in parts per million of a drug in the bloodstream after T hours. How many parts per million are there? How many more parts per million after 20 hours than after 10 hours? So they're asking me to do C of 20 minus C of 10. They want me to evaluate this concentration function at 20 hours, evaluate the concentration function at 10 hours, and find the difference between those, because we want to know how many more milligrams there are in the bloodstream after 20 hours than after 10 hours. So I did negative 0.05 times 20 squared plus 2 times 20 plus 2 minus negative 0.05 times 10 squared plus 2 times 10 plus 2. And I ended up with 22 minus 17, or 5. So F is my choice for number 2. 3. F of x, g of x are given. What's f of g of 1/4? Well, I notice I'm supposed to find g of 1/4, so let's do g of 1/4 first. G of 1/4 means I go to g of x and I plug a 1/4 in. So 1/4 under the radical plus 2.5. Well, the square root of 1/4, that's 1/2 times 1/2, is 1/2 plus 2.5, or 3. So g of 1/4 is 3. Now I see that I can replace this g of 1/4 with 3. So how do I find f of 3? Well, f of 3 means negative 4 times 3 plus 1, which is negative 12 plus 1, or negative 11. So answer A is my choice for number 3. 4. F of x is this, g of x is this. Which of the following is f of g of x? Well, I'm supposed to take, when I see this notation, I'm supposed to take g of x and plug it into all the x's of f of x. Remember, f of x is x squared plus 1. But into that x, I have to plug g of x. So f of g of x will look like g of x going into the x of f of x and getting squared, and then 1 being added to it. Remember, this is foiling. This is not applying the exponent. It's 3x plus 1 times 3x plus 1 plus 1. When I FOIL here, I get 9x squared plus 6x plus 1 plus 1, or 9x squared plus 6x plus 2. And that corresponds with choice K. K for number 4. Number 5. The box here says that I should use this graph for problems 5 and 6. What is the range of h of x? That's the graphed function. Well, it looks like the highest the graph goes is 2. And those aren't arrows at the endpoints, those are dots, and they both have the same y value, and when I count, I see the y value is -4. So my range would be from -4 to 2. And that corresponds with choice E, all the real numbers between and including -4 and 2. Question 6 asks us to find on -5 to 5, for how many values of x does f o h of x equal 0? Well, h of x equals 0 is asking us about x-intercepts. How many x-intercepts are there? Not where are they, just how many are there? All I needed to know was that this notation was asking me about x-intercepts, and then I can look at the graph and count the x-intercepts, or places where the graph crosses the x-axis, and I count 4 x-intercepts on the graph, and so choice K is my answer for number 6. 7. For what values of x does r of x have a vertical asymptote? Well, r of x is defined this way, and we remember that by setting the denominator equal to 0, we can find places where the function is undefined and has a vertical asymptote. So x squared equals 16, and when we take the square root, don't forget the plus or minus, 4. So x has r of x has vertical asymptotes at these two places, and so choice D is my answer. Choice D for number 7. 8. Which of the following functions could be used to generate the piecewise graph below? Well, I don't want to really redraw this one. I do want to say, see that open circle there? Well, that means that this isn't my answer. It's very close to my answer. I see the downturned absolute value, but I also see that the downturned absolute value has been shifted up 1. So I wouldn't want this either because there's no plus 1 here. But I also don't want it because there's an open circle here, which means at x equal to 4, the function has no value. So nothing with an equal to. So this one's going away, and that's the only one with the equal to. Okay. Then I'm looking for negative absolute value of x, but shifted up 1. And that's not this one, because that's not shifted up 1. This one is shifted up 1. It doesn't have the equal sign. However, over here, this is the line y equals -3, not y equals -3x. So that's why choice J is my answer. The absolute value has been flipped upside down and shifted up 1. Then there's a horizontal line at -3 and no equal to sign. So J is my answer for number 8. Okay, number 9. Number 9. Well, there's this interesting notation. When I see this notation, I should understand it as the bth root of A. That means A goes under the radical symbol, and B is the index for the radical. So when I see 64, symbol 3, that means a 64 goes underneath the radical, and 3 is my index. Oh, so this question is asking me about the cube root of 64. And since 64 is 4 times 4 times 4, I know that 64 symbol 3 would be equal to 4, and that's why choice A is my answer. 10. Log base 5 of 25x equals 2. Well, if I use my log properties to rewrite this as log base 5 of 25 plus log base 5 of x, and then say, well, log base 5 of 25 is log base 5 of 5 squared plus log base 5 of x equals 2. And then I use the power rule to bring this down, and I get 2 log base 5 of 5 plus log base 5 of x equals 2. Well, remember we said a few minutes ago that log base b of b was 1, so log base 5 of 5 is also 1. 1 times 2 is 2, plus log base 5 of x equals 2. And when I subtract 2 from both sides, I get log base 5 of x equals 0. Now, there are a couple of ways I could do the problem from here, but I find the easiest is Mr. Gleese's scorpion tail. So 5 to the 0 equals x, or 1 equals x. And so my answer for this problem is G. G is the answer for number 10. Okay, how about 11? What three numbers should be placed in the blanks so that the difference is the same between these consecutive numbers? 12, blank, 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 and then 32. Well, I see I'm going up once, twice, 3, 4 times between these numbers. So 32 minus 12 divided by 4 going ups. Or 20 divided by 4 means each time I go up I should add 5. So 12 plus 5 would be 17, and 17 plus 5 would be 22, and 22 plus 5 would be 27. And just to check, if I add 5 to 27, it does in fact get me to 32. So the numbers I'm looking for are 17, 22, and 27. That corresponds with choice B. 12. First and second terms of a geometric sequence are 3 and 12. So a sub 1 is 3 and a sub 2 is 12. And we want to know the 24th term. Well, remember the formula for a geometric sequence, a term in a geometric sequence is a sub n equals a sub 1 times r to the n minus 1. Well, we know a sub 1 is 3. I can plug that in right away. A sub n equals 3 times r to the n minus 1. And how do I find r? Well, I can find r by doing a sub 2 divided by a sub 1, which in this case is 12 over 3, or 4. So I know my r value is 4. A sub n, therefore, is 3 times 4 to the n minus 1. Please don't multiply these together and turn it into 12 to the n minus 1. That's not correct and is a common mistake. Now we're looking for a sub 24, which means I have to replace 24 with the n. 3 times 4 to the 24 minus 1, which would be 3 times 4 to the 23rd. And that corresponds with choice J. Choice J for number 12. I really do need to know my basic formulas for arithmetic and geometric sequence, and in pre-cal we'll be covering that in chapter 9, which is what we're going to do after chapter 6. So you might want to take careful note of these problems because I believe chapter 9 is going to be after the ACT, and so here's geometric sequence. Hopefully you had some exposure with this in Algebra 2 last year. 13. What is the amplitude of the function f of x equals 2 cosine 4x minus pi? Well, we know the amplitude is this leading coefficient here, so our amplitude is 2, which corresponds with choice C. Just a word, if I had seen this, negative 2 cosine 4x minus pi, remember, the amplitude is still 2. The amplitude does not include this positive or negativeness out here. It's just the value of that number, how much I go up by and down by. I go up and down by 2, whether there's a negative out front or not. Okay? All right, let's take a look at number 14. 14 says cosine g equals 0.5. Well, there are a couple of tricky, challenging ways to do this problem, but I thought that the easiest way was to look at well, to look at these fractions. 1 minus 1 over sine g. Well, that's 1 minus cosecant g. Yeah, I don't feel like I know anything about that. But 1 minus 1 over secant g, well, isn't that 1 minus cosine g? And cosine g was 1/2, so 1 minus 1/2 is 1/2. Hey, that is the same. And so my choice here is J for number 14. I thought this was perhaps the trickiest question in the packet. It required me to think a bunch about this or to do it in a really awful way, and I didn't want to do it in an awful way. So let's move on then to number 15. 15, the trig function below could be represented by which? Well, you can see by my notes here that I saw the graph at x equal to 0 starting high at 1. And so I thought about cosine with an amplitude of 1 because I'm going up 1 and down 1. Then I noticed that the period goes from 0 to 2 pi, just like cosine goes from 0 to 2 pi from high to high point. So I was thinking b was 1, and I was thinking I was looking at a cosine graph. But when I looked down at all my choices, I said, uh-oh, none of these are cosine. They're sine. Well, then I thought, what about transformations? When I thought about transformations of the sine graph, I thought, well, this shifts the graph pi. So if I go over to pi, am I looking at a sine graph starting here? Well, no. Starting down here and going up, that would be negative cosine. And I thought, well, what about this one? Plus pi. So if I go back pi, oh no, that's also negative cosine. What about 2 pi? Well, if I shift 2 pi, because the period of sine is 2 pi, that brings me back to where I start, and so this looks just like sine of x, and I'm not looking at sine of x here. This shifts the graph right pi over 2. So if I'm starting here, do I have a sine graph starting here? Well, I have a negative sine graph starting here because I'm going down first. So that one didn't work. So that's why E is my choice here. I'm shifting left pi over 2. So I start here and go up, and lo and behold, it looks like regular sine when I start there. So E is my choice for number 15. E for 15. Let's take a look at 16. H of x equals 3x minus 1. H of 5 minus h of 2. Well, h of 5 is going to be 3 times 5 minus 1, or 14. And h of 2 will be 3 times 2 minus 1, or 5. So we're looking at 14 minus 5, or 9, and so h is my answer for number 16. 17. We're about halfway done now with 17. We're asked to find f of x plus h. Well, that means I'm supposed to plug in x plus h into all the x's of f of x. Well, here's f of x. F of x equals x squared plus 3x minus 5. And so when I replace all the x's with x plus h's, I'll have x plus h squared plus 3 times x plus h minus 5. Foiling here will get me x squared plus 2xh plus h squared. Distributing here gets me 3x plus 3h, and I have a minus 5. There are no like terms to combine, so E is my answer for number 17. In pre-cal, we did this problem in chapter 1. 18. 18 says a of x is this square root and b of x is this cubic function, and they want to know the value of a of 3 over b of 2. Okay, so a of 3 will be the square root of 3 squared plus 7, which is 9 plus 7, or square root of 16, which means a of 3 is 4. And b of 2 means I plug a 2 into the b function. 8 minus 1 is 1. And so I end up with 4 over 1, or 4 is my choice, and that's why J is the answer to number 18. 19. 19 asks us to find g of h of 3. Okay, so with g of h of 3, I'm going to start by finding h of 3. I'm going to read on this h table to x equals 3, and I'll see that the output is 0. So h of 3 equals 0, which means in this original expression, g of h of 3, I can replace h of 3 with 0, and now it'll look like g of 0. When I go back to my table, but this time read the g column, when the input is 0, the output is negative 1. So g of 0 is negative 1, and therefore A is my answer for number 19. 20. We've got a graph of f of x, we've got a graph of g of x. F of x is this absolute value graph. Passes through the point 0, 2. G of x looks like a square root graph going through negative 4, 0, and also through 0, 2. Is f of 0 negative 4? Well, f of 0 is 0, 2, so no, that's not true. G of 2 equals 0? Well, if I go over to 2, the value of the g function is not 0. Is f bigger than g for all values of x? Well, f is definitely bigger over here and over here, but between this point and this point, f is actually less than or below g of x. So that's not true. How about 0, 2 is a solution to the equation f of x equals g of x? Well, we remember that when we see this function notation, we're wondering about the point of intersection. And I see 2 points of intersection, and certainly one of them is 0, 2. So I like this answer, J, for number 20. J for number 20. How about 21? Which of the following describes the range of the function h of x equals 4x squared minus 9? Well, when I think about this parabola that's been stretched and shifted down 9, I'm thinking about a graph like this. And I'm asked, what's the range of this graph? Well, it seems to start at negative 9 and go up forever. So that is choice C, all real numbers greater than or equal to negative 9. 22. Piecewise function below. Find f of 6. Well, 6 is an x value, and so I'm looking on which domain I can use 6. When I see the way the function is defined, I use this piece only for x values less than or equal to 0. I use this piece only for x values bigger than 6. And I use this piece for x values bigger than 0 but less than or equal to 6. So if I want to know f of 6, I have to use just this piece. Not this one, only this one, because 6 is one of the x values included from bigger than 0 but less than or equal to 6. So I plug my 6 in for that x. 2 times 6 is 12, minus 9 gives me 3, which is why f is my answer for number 22. 23. Which of the following could generate the piecewise function below? Well, I notice there's a square root graph shifted down 1. I see square root of x shifted down 1. That means this goes away, this goes away, this goes away, because none of these have a square root of x shifted down 1 function. I've only got this one or this one. Now, I notice over here I have a negative slope. I'm going downhill. This one has a positive slope. This one has a negative slope. That's why A is my choice for 23. 24. Between negative 2 and 2, f of x, which is 1 minus x squared, or if you use the commutative property, negative x squared plus 1, that's a flipped upside down parabola shifted up 1. This question says, on the interval from negative 2 to positive 2, where does this function have a maximum? Oh no, it doesn't say where, it says what is the maximum value. The maximum value is 1, and that occurs at x equals 0. The maximum value is 1, and so my answer here is G. G for number 24. It seems like so many of these questions in this packet relate to stuff that we learned in Chapter 1 in Pre-Cal. Some of it, though, deals with Chapter 3, and some deals with Chapter 9. Let's take a look at 25. 25. The graph below shows Aaron's distance from home over a 1-hour period, during which he first went to a library to return some books, and then went to the post office, and then returned home. Well, when I looked at this graph, I said, you know, he started at home, and then he walked for 5 miles in 15 minutes to get to the library. 5 miles in 15 minutes is pretty fast. That's pretty fast walking you got there. Maybe he drove, because it doesn't say he walked. Then this flat line means his distance didn't change, so he was at the library for 10 minutes, and then he left the library and went to the post office. The post office was 2 miles away from the library. He's now 7 miles away from home. He spent 15 minutes at the post office, and then after the post office, he returned home. So the post office is 5 miles from Aaron's house? No, it's 7 miles. Aaron traveled a total of 7 miles from the time he left home until the time he returned. Well, this distance from home says it goes up to a maximum of 7 and then goes back to 0. So he traveled 7 miles out to the post office and then back home. Oh, well, wait a second. I got to read this question a little more carefully, don't I? Aaron traveled a total of 7 miles from the time he left home. Well, that's not true. He traveled 7 miles just to get to the post office and another 7 miles to get back, so that one doesn't work. All right, well, let's see. The post office is 7 miles further from Aaron's house than the library is. No, the library was at 5 and the post office is only at 7, so the post office is only 2 miles further, so that one doesn't work. How about D? Aaron spent 10 minutes at the library and 15 minutes at the post office. Well, the increments here are 5 minutes for each mark, and he was 2 increments, so 2 5s is 10. He was 10 minutes at the library. And look, he was 3 increments or 15 minutes at the post office. There we go. D is the choice for 25. Okay, 25 was D. How about 26? Factorial. 6 factorial over 2 factorial, 3 factorial. Well, we know 6 factorial is 6 times 5 times 3 times 2 times 1. 2 factorial is 2 times 1. times 3 factorial, which is 3 times 2 times 1. Notice these can all cancel, and we can take a 2 out of here, and so we end up with 15. Oh, that seems strange. I left out the 4. Thank you. I knew there was something missing. Times 4, or 60. There we go. This may bear worth doing again. 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1 times 3 times 2 times 1. These cancel. I can take a 2 out of here. 30 times 2 is 60. And that's why choice K is my answer for 26. 27. What is the value that satisfies the equation log base 2 of x equals -3? And if I scorpion tail this, or log base 2 of x equals -3, if I exponentiate, I get x equals 2 to the -3, or x equals 1 over 2 to the third, or x equals 1/8, and that corresponds to choice C for number 27. How about number 28? 28 says, for which value of x is this equation true? Log base 2 of x plus log base 2 of 8x equals 5. Well, this tells me I can combine these two logs into one log using my product property. X times 8x equals 5. Or log base 2 of 8x squared. If I exponentiate, I end up with 8x squared equals 32, or 2 to the 5th is 32. And then when I divide both sides by 8, I get 4. X equals plus and minus 4. However, this is a must-check situation. Remember, I can't take the log of a negative number. So x equals 4 is my only solution here. And that, square root of 4 is 2. I can't plug a -2 in here, which means x equals +2 is my only solution, and that's choice F. Choice F for number 28. 29. The first 4 terms of an arithmetic sequence are this. What is the 20th term? Remember, the recipe for an arithmetic sequence is a sub n equals a sub 1 plus n minus 1 times t. D is the common difference, how much these values go up or down by each time. Well, I notice that these values aren't going up, they're going down. Down by 4, down by 4, down by 4. So we know that D equals -4. We also know a sub 1 is 25. So a sub n is 25 plus n minus 1 times -4. If I distribute that -4, I get a sub n equals 25 minus 4n plus 4, or a sub n equals 29 minus 4n. They asked for the value of the 20th term, so a sub 20 would be 29 minus 4 times 20, or 29 minus 80, which is -51, which is why choice B is my answer for number 29. 30. The 5th and 6th terms of a geometric sequence are 3 and 1. So a sub 5 is 3, and a sub 6 is 1. And we remember from that earlier problem that with a geometric sequence, the recipe is a sub n equals a sub 1 times r to the n minus 1. Okay, well, we don't have a sub 1. In fact, that's what they're asking for here. But we can find r. Remember, we can take the value of a sub 6 and divide it by a sub 5 to get our r value of 1/3. So a sub n equals a sub 1 times 1/3 to the n minus 1. Now I'm going to take one of these ordered pairs that I was given, where my n equals 5, my a sub n is 3, and plug those values in. 3 equals a sub 1 times 1/3 to the 5 minus 1. Well, 5 minus 1 is 4, and 1/3 to the 4th is a sub 1 times 1 over 81. Oops, not 18, but 81. If I multiply both sides by 81, I can get a sub 1 by itself, and I see that a sub 1 is 243, which is why K is my choice for number 30. K is my choice for 30. 31. The finite arithmetic sequence has 5 terms, and the first term is 2. What's the difference between the mean and the median of the 5 terms? Well, this is an arithmetic sequence, which means it goes up by the same amount. Now, they don't tell me what that amount is. I could try picking some random numbers and doing this problem and seeing what I got, but I'm actually going to do this using just D to represent the common difference. So let's think about this for a moment. My n values here and my a sub n values here. They told us that the first term, the value was 2. And then for the second term, we went up by some amount. I don't know what that amount is, but I know that common difference is normally called D. So if I went up by D, I would have 2 plus D. My third term, I would go up another D, or 2 plus D plus D, or 2 plus 2D. My fourth term would be 2 plus 3Ds, and my fifth term would be 2 plus 4D. If I write these out, 2 plus 2 plus D plus 2 plus 2D plus 2 plus 3D plus 2 plus 4D, I notice that I get 1, 2, 3, 4, 5 of those 2's, and 1 plus 2 is 3, plus 3 is 6, plus 4 is 10D. Now that's the total. To find the mean, I add up all the numbers and divide by how many numbers there were. And I get 2 plus 2D. That's the mean. The median is what happens when I put all these numbers in order, from smallest to largest. Here's the smallest, here's the largest, and here's the number in the middle. 2 plus 2D is the median. Well, what's the difference between these? I get 0, which is why my answer is A for number 31. If this was too abstract for you, you could certainly go back and do this problem by choosing a random D value. The first time I did the problem, I think I chose a D value of 8. Works the same. I just wanted to do it with D's so that I could know that this would work for any amount of going upness, any D value. Okay, 32. 32 says x plus y is equal to what? And they give me a 60-degree angle. 60-degree angle. And they say this is xy. Well, we know from our unit circle that when this is a 60-degree angle, this is 1/2, and this is root 3 over 2. If this is my x and this is my y, and they're asking about x plus y, I'm just going to add 1/2 plus root 3 over 2. This is a number bigger than 1 plus a little more. The only number bigger than 1 here is k, but if you're not sure, you could always pull out your calculator and check. Okay, last 3 questions. 33. Graph of cosine g of x equals cosine 3x is shown below. When does g of x equal 0? Remember, we said earlier that this is asking about x-intercepts. And I see there's an x-intercept halfway in between 0 and pi over 3. So if I average those two values, I end up with pi over 6. When I convert from radians to degrees, pi over 6 is the same as what angle? Well, that's 30 degrees. And the only one of my options that has 30 degrees in its list is choice C. 34. X is bigger than 0, A is x cosine squared, B is x sine, A is x cosine theta, B is x sine theta, then what would the square root of A squared plus B squared be? Well, I'm going to take that A and square it, that's x cosine theta squared, and I'm going to take that B and square it, that's x sine theta squared. And here, there's no plus or minus sign in here, so I can just apply that exponent to each of these and get x squared cosine squared theta plus, same goes here, x squared sine squared theta. Now I notice I have an x squared in each of these terms, so I'm going to factor out that x squared, leaving me cosine squared theta plus sine squared theta. Cosine squared plus sine squared is one of our Pythagorean identities. That's 1. 1 times x squared is x squared. Under that square root of x squared is x. And so choice G is my answer for 34. And the last problem, 35, which of the values is equivalent to tangent theta cosine squared theta plus tangent theta sine squared theta all over sine theta? Well, I notice I can pull a tangent out of each of these two, and I'll have cosine squared theta plus sine squared theta. And we just said a moment ago that cosine squared plus sine squared was a Pythagorean identity equal to 1. So this is 1 times tangent, or tangent theta over sine theta. I can write this as tangent theta times 1 over sine theta. And I like to do that because tangent can be written as sine theta over cosine theta times 1 over sine theta. These signs will cancel, leaving me not cosine theta, but 1 over cosine theta, which is secant theta. 1 over cosine theta, which is secant theta, which is why choice D is my answer for number 35. Okay, so that's all the questions from this packet, and it only took 48 minutes. Not bad. Have a great day.